Hello everyone, welcome to Learning Management System, Department of Collegiate and Technical Education. Today I am taking class for the 5th SEM Diploma Electrical and Electronic branch students. The subject is Electrical Estimation and Costing. The subject code is 15EE54T. Today the topic is to find the KVA rating of transformer for the given load. Let us find the rating of transformer to supply 50 HP for a factory. 50 HP means that is the total connected load. The electricity board persons will not sanction 50 HP load. So that is the total connected load. They will sanction only the maximum load at any instant. Suppose, for example, in this factory, 5 numbers of 10 HP motors are there. At any instant, there may be 3 motors are running. So that is the maximum load is 30 HP only. So for that reason, a diversity factor we have to consider here. Diversity factor is the ratio of total connected load over maximum load at any instant. So normal assumption for the diversity factor is 1.5. Here, the maximum load at any instant equal 50 divided by 1.5, that is 33.33 HP. It is the motor output. We have to consider the motor input requirement. So then we have to consider the motor's efficiency. The normal assumption is 80%. So that means input power required equal motor output divided by the efficiency, that is 33.33 divided by 0.8, so that is 41.66 HP. So if we consider in kilowatt, we have to multiply this 41.66 by 0.735, that gives 30.62 will be in kilowatt. We have to consider the power requirement in KVA. So for that, we have to assume the power factor. The power factor normal assumption is 0.8. So then the power requirement in KVA equals the power input divided by the power factor. So that is 30.62 divided by 0.8. So that gives the value 38.28 in kilovolt amps. But the available transformer rating is 63 kVA. So the specification of transformer is 63 kVA, 3-phase 50 Hz, 11 kV bar 433 volts distribution transformer. Consider the second example. Find the rating of transformer to supply 100 HP for a factory. So 100 HP means that is the total connected load. As I said earlier, we have to consider the diversity factor. So normal assumption is 1.5. Then the maximum load at any instant equal 100 divided by 1.5. So that gives 66.66 HP. So this is the motor at output. So we have to consider the motor input power requirement. So for that, we have to assume the motor's efficiency. So normal assumption is 80%. Then the input power required. So that is total input power required equal the motor's output divided by the efficiency. So that is 66.66 divided by 0.8. So that gives 83.33 HP. So if we convert this HP into kilowatt, So then we have to multiply this 83.33 by the factor 0.735. So that gives 61.25 in kilowatt. We have to consider the power requirement in KVA. So for that, we have to assume the power factor. The normal assumption of power factor is 0.8. So then the power requirement in KVA equal the motor input power in kilowatt divided by the power factor. So that is 61.25 divided by 0.8. That gives 76.56 in kilovolt amps. But the market availability is 100 kVA. Then the specification of transformer required for this load is 100 kVA, 3 phase, 50 Hz, 11 kV bar 433 volts distribution transformer. Let us consider one more example. Find the rating of transformer to supply 300 HP for a factory. As I said earlier, 300 HP means that is the total connected load. So then we have to consider the diversity factor. The normal assumption is 1.5. Then the maximum load at any instant. Well, the total connected load divided by the diversity factor. So that is 300 divided by 1.5. That gives 200 HP. So this is the motor output. So we have to find the total input power required. So for that we have to assume the motor's efficiency. So normal efficiency assumption is 80%. Then the total input power required equal the motor's output divided by the efficiency is 200 divided by 0.8. That gives the value 250 HP. That is the total input power required. So if we consider the power requirement in kilowatt, then the 250 is multiplied by the factor 0.735. So that gives the value 183.75 in kilowatt. Here we have to consider the power requirement in KVA. So for that we have to consider the power factor. The normal assumption for the power factor is 0.8. So the power requirement in KVA equal the input power in kilowatt divided by the power factor, that is 183.75 divided by 0.8. That gives the value 230. But the market availability is 250 kVA. The specification of transformer is done 250 kVA, 3 phase, 50 Hz, 11 kV bar 433 volts distribution transformer. The reference books are is as follows: Estimation and Specification by Gangadhar Rao. Second one, Estimation and Specification by Raghunath Rao. And third one, Estimation and Specification by Raghavendra Rao. This is the team responsible for e-content development. Thank you all for being with us. Please write to us your suggestion about content, tools and format, etc. to lms.dtek@gmail.com. Thank you. Let us meet again in the next session.